Hi, welcome to the Mathemagic channel. Today we attempt question 6 in the AMC 12 problem set. This is from 2022. Perhaps try the question first and then watch the video solution. Thank you so much. Let's get started. Okay, so as mentioned, we do have 100 sets of 10 elements each, and in each one of these sets we have multiples of 7. So if you think about 1, 2, 3 up to 10, then 7 is contained, and then if you think about 11 to 20, then you have another 7 in there, and then between 21 and 30 you'll have 21 and 28, so you have 2 multiples of 7. So first thing to think about here is probably how many multiples of 7 exist between 1 and 1000. And so one thing you can do is you can try and find a large value, which is the largest value below 1000, which is divisible by 7. So you can actually put a number on it. So if we have 700 divided by 7, and then maybe the next multiple that we can use is 280 divided by 7. So this gets us to about 980. And then we can use 14 and say 14 divided by 7. So this is actually altogether, if you look at it as a number, this is 994 divided by 7. And if we break this division down, we realize that it's 100 plus 40 plus 2. So we have 142 multiples of 7, which are contained between 1 and 1000. So this is a good first point of information that we have 142 multiples of 7. Now the tricky bit is to think that in between all of these intervals, well, we either have 1 multiple of 7 or we actually have 2. So between every single one of those sets, or inside of each one of these sets, we have 1 or 2 multiples. So if you think about it, 1 to 10, you have 1 multiple, 11 to 20, you have 1, 21 to 30, you have 2. And then from 30 to 40, you're going to get 35, which is just the 1. And then between 40 and 50, you'll have 42 and 49, which is just 2. The mathematical reason why we have 1 or 2 specifically multiples of 7 contained in each set is that the number 10, which is the size of each set, is actually bigger than 7, but smaller than 14. So each time, you're either going to have 1 or 2, and that's pretty clear from the fact that 10 is contained between 7 and 14. So this fact, the fact that we have 1 or 2 multiples of 7 per set, brings about an interesting point. We have 100 sets and we have 142 multiples. Well, this is really interesting because if we have 100 sets and we have 142 multiples, and each one of those sets either has 1 or 2 multiples of 7 and nothing else, like there are no sets which contain 0, there are no sets which contain 3, then we have 42 sets which have too many 7s. And in those 42 sets which have too many 7s, well, those are the 42 sets which contain 2 7s. And so that is a very, very smart little trick that you can use here to say, well, actually the answer here is going to be 42. And so we can pick the answer B, which is 42, and be very happy with the fact that we found a nice, neat little trick to solve this Olympiad problem. Thank you for watching the Mathemagic channel. As usual, please like and subscribe and share any video to your friends or to anybody who likes mathematics so that you can support the channel. We appreciate your support a ton, and we shall see you on the next one. Thank you. Bye-bye.